Hello everyone, welcome to Code with Cougar. This video is going to be our first video in our journey to learn C#. So in this video, we'll be mainly talking about variables, constants, and various data types in C#. So for that, let's open our Visual Studio and create a new project. So click on create a new project. In this list, we are going to select a console application for this video. If you guys don't see console application here or here, so you can just simply search it here, write console. So it's going to bring all the options for console application. So we are going to use console app.NET framework. Double click on that. Then it's gonna ask us to give a name to our project. So we are going to give it C#, C# .NET. Okay, this is going to be our project name, and this is the location the project will be stored. If you guys don't like the default location, you can always change it by browsing a new location in your computer. You can simply double click on these three dots and it's going to open a window where you can select location to store your projects. So Visual Studio is going to create a solution same as our project name. We can change our solution name also. What a solution is, it is basically like a container that contains multiple other projects, C# projects. It can also contain DDLs and libraries so that we can simply use in our project. So we'll be talking about solutions and how to create our own library and DDLs. For a moment, for this video, just think of a solution like a container that contains multiple other projects. Okay, this is the .NET framework version we'll be using. Okay, click on create button to create our project. This is the setup of our project. Visual Studio created. Hope you guys have a basic understanding of the different components of a C# application created by Visual Studio. So hope you guys have now a basic understanding of what what are different files within our project. So as we can see, this is our solution name C#.NET, and within our solution right now we have only one project, which is C#.NET. So as we going to talk about variables, let's create a new project within our solution. So to create a new project within a solution, we can right click on a solution, go to add, and select new project. We are going to select console application again, or we can use this project, but let us make another project within our solution. Let's select console application .NET framework. Let's call it variables, constants, data types. Okay, so this is going to create the new project within our solution. Create. Right now we can see that we have two projects within our C#.NET solution. It says 2 of 2, means 2 of 2 projects are here. So one project, two project, and we can see that C#.NET is bold, and variables, constants, data types project name is not bold. Means that it is going to be our startup project. If we go to C# .NET program.cs, if we write CW and press tab, let's write something. This is C#.NET project. Okay, right now if we run our project, it's gonna execute this project. If we click on this start button, it's going to execute this project because the name of this project is bold, and this is our startup project. Okay, a window popped up, it printed this message, and the console window was closed. So to keep the console window open, we are going to write console console.read or read line. Okay, it's going to wait for the user to press a key, then it will close the console up window. So it prints this is C#.NET project, and it's waiting for the user to press a key. Okay, but if we wanted to change the startup from this project to this project, right click on this project and select set as a startup project. Right now this is our startup project. If we write something here, variables, then if we click on a start button, it's not going to execute this project. It's going to instead execute our second project. Let's write console.read here also to keep the window open. So variables. Okay, so let's talk about our topic. Let me print some comments here. So before we start our discussion today, there are two ways to comment our codes in C#. One is single line comment that we can use only two double slashes, and we write our comments. So comments are basically extra informations or documentations that we need to write about our code to explain what is happening. If other programmers or software engineers try to read our code, they can read the documentation and understand what is all this function about or this variable about. Okay, and there is a second way is that we can have multi-line comments by writing slash star asterisk and asterisk slash. So between this we can write our comments. This is multi-line comment. So these are two ways that we can document our code in C#. So without further ado, let's talk about variables in C#. So basically, what is variables? So variables are names given to a storage location in memory. It is like a container that we create in memory in order to store values or information within them, and in the future or later on in our program we can easily access that information or values that we stored in a memory location. And we can store strings, numbers, booleans, character values, and we can later on use them. Not only we can use these variables, but we can if we want it, we can change the value of these variables throughout our program. So let me show you how we can really define a variable in C#. To define a variable, we just simply provide the data type for variable. Suppose we want to define an integer variable, integer num or number equal to 10. This is a variable we created. We have given a name to our variable and we assigned a value 10. So the rule is first we provide the data type of the variable, then we give a name or an identifier to our variable, and then we assign a value to it. Assigning a value is optional. At the time of declaration, we can also have a variable int I without being assigned to a value. This is also a valid variable declaration. But remember, in C#, we can define a variable without initializing it, but we are not able to use that. Okay, so let me show you a website here that visually represents what is happening when we define a variable. Suppose we defined a variable int I equal to 1000. So what the compiler is going to do, it's going to reserve a memory area same as size of our data type and call that memory area I. Suppose we have this memory area or container. This was reserved for I variable, and the value 1000 was stored in this memory location. This memory location has a complex address. Each memory cell in the RAM has addresses. So instead of accessing this memory location by address, we are giving that a human readable name. Think of variables like an alias or other name to memory locations. So throughout our program, we can access this value and memory location by I. Or we can use human readable names like in my number equal to 1000 or age equal to 20 or value or size equal to 1000, whatever, so that we can understand instead of memorizing this memory address. So these are dynamically allocating memory. They are creating an object of type foo. We are not going to talk about these at the moment, but this one, just understand that when we define a variable, it's going to reserve a portion or a memory location for that variable, same as size of the data type we provide. And if we assign the value, this value will be stored in the memory location. Okay. Let me show you something else here. So what is a variable? A variable is a symbol that refers to a storage location. Suppose we have int I equal to 10, and instead of saying this memory location equal to 10, we just simply say I equal to 10 or age equal to 10 or whatever human readable name equal to 10. And instead of accessing the value by this complex address, we can simply access the value by human readable names we have provided to our variable or identifiers. So hope you guys have understood what a variable is and what we mean when we define a variable. Okay, so integer values in C#, like they can hold up to -2 billion to +2 billion. The range for the integer values are -2 billion to almost 2 billion integer values. So the second thing that we are going to talk is the CIF type. C# is a CIF type language or a strictly typed language. What do we mean by that is that when we define a variable in C#, we have to provide the data type for the variable. Suppose we want to define a string name equal to code with Cougar. Remember that when we define a string variable, the value we assign to a string variable must be inside the double quotes. But whereas the value assigned to an integer value does not need to be inside the double quote. If we provide 10 inside the double quotes, then that will 10 will be treated as a string value, not as an integer value. Okay. And also remember that each statement in C# must terminate by a semicolon, otherwise we get an error. If we don't give a semicolon here, the compiler will not accept that, and it will complain syntax error. Okay, we are gonna give a semicolon here. So if you guys know about Python, Python is a loosely typed or not strictly typed language. So in Python, in order to define a variable, we just give the variable name, example age. If we write age, suppose this is age, we can directly assign it a value without providing semicolon and the type of the value. So the type of the value or a variable will be decided at the runtime for the Python. But in case of C#, since it is strictly typed, the type of the variables are decided or determined at the compile time. That's why if we don't provide the type here, data type here, it's going to give us an error, and the compiler doesn't accept that. As soon as we provide a data type here, the error will be gone. Okay. Next, let's talk about constant values. So these are the variables. Since, as the name implies, the variables are changeable. We can change the variable throughout our program. Suppose we have int name equal to code with Cougar. Let's use this string variable, and if we wanted to print this variable in our program, we can just write console.writeLine name run. Okay, let me write a console.readLine here. If we run our project right now, it printed code with Cougar. Variables are changeable. We can change the values stored in this variable throughout our program. Suppose we want to change the name equal to, let's assign it a new value. Let's assign it code. Okay, and whenever we access name after this line of code, so the value of name is going to be the value of name is going to be code instead of code with Cougar. For this line of code, the value will be code with Cougar, and in this line, after this line of code, the value of the name is going to be code only. Let's print that. The first print statement printed code with Cougar, and the second one printed code. Okay, it's not the case with constants. So constants are an immutable values that we provide to variables. Okay, we can use the const keyword to define a constant variable. So constant, once we defined a constant variable, we have to provide a value or initialize it to a value, and that value will not be changed throughout the life cycle of our program. But whereas in variables, we had the option to leave it without assigning a value, but we will not be able to use that, okay, unless we have not assigned it. If we wanted to use I here, if we say I plus plus or increment the I, so the compiler will not accept that, it's going to give error, okay, because we have not initialized the variable. Unless we have not initialized, we will not be able to use that. If we initialize it, say I equal to 10, then this error will be gone, okay. We can print this error after initializing. We can increment, decrement, and perform whatever operation we want. But that is not the case with constant. Constants must be initialized at the time of definition. Suppose we want to let's define an int const. We are going to use const keyword to define a constant variable, int age equal to 10. So this is a constant or an immutable value that will not be changed. If we try to change the value of age in our program, age equal to, let's say, 22, so the compiler will complain saying that it is a read-only, it's immutable and read-only variable. We are not able to change that. Same case if we wanted to define a constant string, we can say const string, say name equal to code with Cougar. We don't want this variable to intentionally or unintentionally be changed in our throughout our program, so we can define it as constant. It's giving an error because we have already a name identifier here, so we cannot have two variable name of same names in one program. So let's call it name2, and the error will be gone, okay. If we try to change name2, that will not be possible, and the compiler will give error. So the reason behind using constant variables is in our program is to provide security and safety to our program. Suppose we have we are creating a scientific application where a lot of calculations are involved. There are some values in mathematics that are constant all the time, that are not changeable, like we have const float pi. The value of pi is always 3.14. This is a floating pi number, so this value is not changeable. That's why all the time we define the pi values as constant variables, or any variables that we don't want to change. Suppose if it is not constant, and later on in our project we unintentionally set the value of pi to something else, pi equal to, say, 3. So all our results and calculations are going to be wrong. We will get different or wrong results or calculation in our project. That's why constant variables provide security and safety to our project. Okay. Most of the time pi is used to calculate the area of the circle. If we change the value of the pi, so we might have used pi in 1,000 places in our project, so all the calculation will be wrong. So that is why very important to provide some security and safety to our variables and program. Okay, let's talk about some rules regarding the identifiers or variables name. So first rule is that variables or identifiers name cannot start with a number. Suppose we want to have an integer variable. Let's call it 2 age, okay, equal to 10. Suppose we have a variable starting with numbers. This is not a valid identifier name. In order to have a number or a 2 before our age, we can type that in the form of a string. So this is a valid identifier name, or we can say prefix it with a special character like underscore 2age. This is a valid identifier name, or int equal to @2 whatever, so to prevent that from being started with a number. So the second rule is that identifiers cannot have a white space in between them. Okay, identifiers must be all one word. So let's say int, or let's define a string first name equal to like John. Okay, this is not a valid identifier name because there is a white space in between, and the compiler will complain and it will give error. Okay, we can provide underscore in between, or we can give the second word as the first letter of the second word as capital letter. So there should not be a white space between the variable names. The third rule is that the variable names or identifiers names we select should not be reserved keywords. There are plenty of reserved keywords in C#. We have like int is a string is a reserved keyword, int is a reserved keyword. Suppose we want to give a string int equal to like say code. Okay, this is not a valid identifier name because the int is already reserved by the C#. So we can, if we want to, if it happens that our variable name or identifier name conflicts with reserved keywords, we can provide an underscore in front of them and the error will be gone, or we can provide something else to make it distinct from the reserved keyword. Then it's a good practice to have meaningful names for our variables or identifiers. Suppose someone tries to say a string last name, they give ln equal to say Kim. Okay, last name equal to Kim. So this is not readable, and later on in our project we might forget that what was ln referred to, or if someone else tried to read our code, they will not understand what ln means. So it's a good programming practice to give always meaningful to our identifiers. So a string name or first name equal to whatever. Okay, this is a meaningful name. It also okay, I think we have first name. Let's call it first name 2. Okay, this is a meaningful name. It makes it easy to maintain our project or program later on. If we wanted to go through our project, if we see first name, we instantly understand this is a first name, and if someone else try to read our code, they understand. So the first name is a meaningful variable or identifier name and compared to ln, if someone else read our code, they don't understand what ln means. Okay, it's always good practice to provide meaningful names to our variables. Then let's talk about some naming conventions about identifiers or variable names. There are mainly two naming conventions. One is camel case. So where in camel case, the first letter of all the variable names, the first word of the variable names start with a small letter, and the second and third and other words in our variable name must start with a capital letter. Suppose we have a string first name equal to a string. Okay, this is camel casing. We are starting the first letter of our a variable name with a small letter and the other word letters start with capital letter. Okay, since we have the first name already, let us call it my age equal to 10. Okay, this is camel case letter. Suppose we have a string address of you or your address. Okay, so this is a camel casing variable name. The first letter of the word start with a small letter and all other words start with capital letter. Then we have Pascal naming convention. In Pascal naming convention, all the letters in our variable name starts with uppercase. Suppose we have int first name equal to code. So in Pascal, all the first letters start with capital. With capital letter. Okay. So mainly variables name. I myself use variable camel case for variable names, function names. I use Pascal case or Pascal naming convention for constants and class names. Okay, so if you guys have come from C or C++ background, in C or C++, always the constants are all caps letters. Suppose we have int max equal to say 10. So all the it's a good practice to provide all caps letter for constant variables. Okay. And then let's talk about data types in C#. In C#, data types are used to specify the type of the data the variable can hold. Okay, we said the type of this first name is going to be a string. So the only type this first name can hold is a string values. It cannot hold integer or floating point numbers. If we try to change the first name to say we want to assign it an integer value, the compiler will give error because the types are not matching. The right side type is an integer type, but the left side type is a string type. The compiler gives error. Okay, same case with integer, floating point, character, etc. There are two types of data types in C#. So mainly we have primitive and non-primitive data types. So in this video, we're not going to talk a lot about the difference of primitive and non-primitive data types. So just understand that primitive data types are predefined data types such as byte, integer, boolean, int32, a string. These are a string is not primitive data type. So and we have non-primitive data types such as user-defined data types such as classes, enums. So if we define a class that is a user-defined data type, that's non-primitive data types. Okay, let me show you some So if we look at this photo, I found it online. So C# data types are broadly classified into two types. We have value type and reference type. Okay, we will talk about what is the difference between value type and reference type. We will make a separate video about that. So then the value types are predefined data types which are already in C#. So for example, we have integer data types. We have int, we have float, we have double, real numbers, we have double, we have decimal, boolean data types, we have true and false, we have character data types that holds only one character. Then user-defined data types of value type is enumeration, structures. So the main difference between a value type and reference type are that when we pass a value type to a function, it's passed by value. All the value will be copied and to the function. But if we pass a reference type to a function, only the reference or address to that variable or to that object will be passed to the function. So we are going to talk about the difference between the reference type and value type in details in future videos. So we have of reference type, we have two predefined data types. One is a string, an object. Okay, then we have user defined data type, that we can define our own data type using classes, so arrays or user defined data types, interfaces, delegates, etc. Okay, there's another image I found. Is explains about the primitive data types we have. These primitive data types are mostly used in C#. We have integral numbers. Of that, we have byte is a data type. So byte can take only 1 bytes of memory in RAM. It can store numbers from 0 to 220, 255. Remember that all data types and identifier names start are all lowercase in C#. These are the data type names to in .NET framework. Each data type in C# is corresponded or connected to a type in the .NET framework. When we run our project in C#, behind the scene, all these data types in C# will be connected to its corresponding type to .NET framework. Suppose short in C# we have short, but short is represented in .NET framework as N16 because a short takes 16 bits of memory. That is 2 bytes of memory. 2 byte equal to 16 bit. Okay, a short data type can store values from minus 32,000 to plus 32,000. Integer takes 4 byte. In C# it's called int, but in .NET framework it's called N32 because an integer takes 32 bit. That is 4 bytes. Okay, 1 byte equal to 8 bit. 8 into 4 equal to 32. So an integer variable can store from minus 2 billion to 2.1 billion integers. Okay, long we have, if we wanted to store long or very large numbers, we can use long data type, which takes 8 bytes. Then we have real numbers. We have floating point numbers that's equal to single type in .NET framework. A floating point number can take 4 byte, and this is the range we can store. We have double, which takes 8 byte. We have decimal, which takes 16 bytes. We have character values that store a single character, A, B, C, whatever, that takes 2 bytes of memory locations. These are Unicode characters. Then we have Boolean data types, which stores only 2 values, true or false. So this takes only 1 byte in memory. It can store only true or false values. So this was a quick video on data types and how to define our own our data types and assign values. So hope you guys have learned something. In the next video, we are going to talk in details about different data types, user defined and primitive data types in C#. Thank you for watching, guys. Please don't forget to subscribe to Code with Cougar, and see you in the next video. Bye bye.